Hello. For me, I'm going to apologize. I have a bit of a hoarse voice today, but unfortunately I need to have a little I have a little cough. My name is Lauri Saks, and I will be presenting a collective work. As you can see by the numerous authors, most work has been done by other people, so they deserve the praise. And if you have any issues, then I will be responsible. And I'm not only working for the University of Tartu, but also Estonian University of Life Sciences. And also we'll be talking about the nutrition of cormorants in most precisely on the estuary of the Pärnu river. And a bit of the background information: cormorant is one of the most popular birds in our coastal areas and one of the largest represented species, and they're increasing. And this increase has been quite exponential, because if we had few fallbacks in the beginning of the 2010s, then as we can see from the graph, there was no stabilization in the situation, because one of the limiting factors is the access to food, and that's not an issue for the cormorants. And the reason is that cormorant is a very efficient eater, mostly eats fish, and even in a situation they are an opportunistic feeder. They will eat what is most abundant in the waters, and as our previous research has shown, that even in the situation where cormorants mostly eat mass fish, for example, in 98 they mostly used mother fish, and unlike that, the proportion of some fish in their diet could be marginal. But even with pike perch, as we have an example here, who only made up 2 to 3% of cormorants' food, and that was at the time when there were 10 times less cormorants in Estonia. But even their predation in the Väinameri area was quite high, up to 10,000 juvenile pike perch annually. But again, I'd like to remind you that this was when we had 10 times less cormorants. And the impact is also seen in the local fish population, mostly in the spawning areas, because if we want to limit the population, then the easiest thing is to reduce the spawning. And with fish, it means that you need to get the fish out of the spawning areas, and with that you will remove all species from the population. And we saw this in the Käina Bay area, where in 10 years, when cormorants settled there, some species of fish drastically decreased and some increased. We also mentioned roach before, so we had 65 times less of roach. So quite a notable effect. And the impact is not only with fish, because cormorants, as you can see on the first graph, they also settle in our little islands. Then it's no surprise that there is impact to other species, first and foremost, for nesting competition. These is data that hasn't been published before. This data is from the Environmental Board, when they were counting the nesting birds on smaller islands. And as you can see from the graph, that when cormorants settled on smaller islands and had their colonies there, then the bird biodiversity index on the islands decreased quite rapidly, while at the same time on other islets it increased. So it stabilized for a while, but we need further analysis to look into why this stabilization took place. But we also have another slide that covers that and discusses on the potential reasons. This is cormorant colony in Matsalu, where around the 2010s cormorants disappeared from the colony, and the red line describes other nesting bird species diversity index. And now we can see that these are antagonistic with cormorant populations. And with cormorants leaving the island, other species became more varied. And as these impacts are well known, and the management of cormorants is something we've done for decades, it hasn't really led anywhere. In 2018, we had a similar event, and then I said that nothing will change unless we do something. And now we're also discussing about doing something, but then they always say that I have this data and it's expired and we need to find out what exactly do cormorants eat. And for that, we are looking into a study that was conducted in the Riga Bay area. It's a very important nesting area. Over 1/3 of all Estonian cormorants nest there, and at the same time a lot of attention has been turned to the fact that cormorants have discovered nutrition areas that they didn't use in the beginning. They found the Pärnu River fish population areas for smelt. So the latest data covers about 5,000 birds, and based on that we should look into whether it has an impact and what do they eat there. So we needed to have a nutrition study to demonstrate what they eat there. Then in 2024 in April they had a nutrition study when in the spawning area of smelt they released cormorants. Why did we not collect pellets? There's a few explanations. To collect pellets from an area where they don't resident and don't nest, because the feeding starts between the nesting area. So collecting pellets is very difficult, but you can get very quick information from the stomach content and able to assess the fish biomass. 7 birds from the 39 who were hunted during that time, we were unable to get any data. So from 7 out of 39. Because we need to have an overall idea what they eat in a day, not just in the morning. And in the stomach content analysis, we detected 5 fish: smelt, wimberbreve, bleak, and perch. And if we look at the subdivision in the food summarized, then we can see that the dominating fish was the smelt, which is not surprising because one thing about the cormorants is that it's an opportunistic feeder. And now with white bream and perch, even with a small selection, they were quite random. And when we look at the mass, then in these cases, what is highlighted is that the smaller fish decrease and larger species increase, but the smelt is still the dominating fish. And if you look at birds, then, as I said, cormorants were hunted during the feeding time, and on average, smelt was 6.5 species per 24 stomachs. They had consumed it before being shot, which makes... and with other species, it was a lot less. Again, we have some mathematical errors in our slide. This was something that was described by a copy-paste disease. And obviously, this figure was 1.7 bleak in grams. But this demonstrates very clearly that the studies show that cormorants still eat fish, and only fish. They're opportunistic feeders. They go and eat from spawning areas, and they move there because it has a lot of spawning fish. So in this case, the smelt. And that was something that we managed to clearly demonstrate in the study. But it also showed that although cormorants mostly eat the dominating fish species, then as opportunistic feeders, they also eat what they get. So with one mass fish species does not mean that other fish species are not the object of cormorant food. And based on the predator's food, we need to be based on the predation pressure. So even a small, if there's a small amount of certain species of fish that is eaten, it could be quite a significant portion in that specific area. And what it also showed is that the impact of cormorants on fish population is dependent on the time and the area. We were looking at the smelt population in the Pärnu River area. It doesn't mean that they eat smelt elsewhere. So if you look at cormorant impact in the coastlines, then we need to look into which fish they eat where. But if we look at the Pärnu River situation, then being aware of the general impact of cormorants to the fish population, then it's not really good to forecast here, but I think we can forecast that if this pressure continues, cormorants eat 400 or 500 grams of fish per day. Now we see the impact on the smelt. They eat there in April, on average 3 weeks, easy calculation. If we have 2,000 cormorants there, they eat 1 ton of smelt. And in 10 years, if we don't do anything, then most likely fishermen weren't able to get smelt anymore. The smelt population will disappear. Cormorants will remain there because if the smelt disappears, they'll start eating bimberbream and then they'll start eating bleak after that, until we reach a situation where we'll catch the limit of cormorants, which means that there's no more fish for them to eat and to populate. That will happen in 50 years, and then we won't have either fish or cormorants. But that does not mean that the fish population would be restored. And I will wrap up with the same slide that I've used for 10 years. So if you have any questions, then I'm more than happy to answer your questions. Thank you so much for this lovely presentation, and thank you for keeping in time. We have several questions. I hope the people here in the audience and who would like to ask, then please add your questions to the Q&A section in Workshop. Then we can ask your questions. But I will start with something that is perhaps directed to the last speaker, but it also ties in with this topic, because in both cases it's the cormorant nutrition. So the question is that in Doris's presentation, that in Võrtsjärve and Lämmi, the fish that are there are bream and roach. So could it not be that we could give more opportunity to small bream and to improve their conditions? Also, we received some sort of an overview from your presentation. Yes, of course, if we, as a biologist, it always amazes me that everyone sees this as a linear issue. We all know from children's book that there should be balance in nature. Cormorants eat fish, for example, bream. They eat bream until they disappear. But we need to remember it's not about a specific 2 species easy model. It's a very complicated nutrition network, and the cormorant, who is an opportunistic feeder, then they can switch over from one fish to the other as soon as it's useful for them. On an individual level, most likely all animals and also fish, the case tends to be that on a population level they're quite opportunistic, and the nutrition index reflects that they often feed from the object that there's most of. But they also prefer other objects. On a species level, we see a specialization. I always have this example that we were collecting pellets from Tondirahu, and they were all mostly, we had lots of cormorants who had mostly cormorants who had been eating sprats, but then we found them who had been eating ruffs. So when it feels better for them to move on to another food object, they will do that. So temporarily could mitigate pressure on other fish species. So if there's a mass species that they tend to eat, then it could ease the situation, but this is not forever. And just to specify, to wrap up, can you conclude that cormorant aids by decreasing juvenile industrial marginal species by giving more space to more important species? Yes, it would be the case if they wouldn't eat the other fish at all. When the predation pressure is quite significant in the Baltic area, we have one of the biggest cormorant population here in Estonia. So this would be the case if they would only eat the most abundant fish, but they don't do that. We also have a question here. You mentioned that the most efficient way to limit fish is to decrease the spawning. I don't know if they mean fish or cormorants, but they say fish. Markus Vetemaa mentioned that with cormorants this could be hunting. Why with fish and birds the limiting is different? Actually it isn't. Markus didn't explain it. But people who have been monitoring cormorants for years in Estonia, then the most effective way is to cut the nesting population, and hunting regulation for cormorants at the moment in Estonia is to minimize the impact of hunting. So that's why we do it in the autumn when we have young birds and the nesting population. Targeted hunting is not very popular. The most efficient way to decrease cormorants is hunting the nesting birds in the spring, which really would decrease the population. Thank you for these answers. Just one more question. Are you planning to investigate the hunted birds, for example, to look into possible marine pollutions, water pollutions? This can most likely, Timo is the expert here. Mostly we are scientists, we like to look into things, and nature science these days, or the morale sees that we also always take the maximum of collected materials. So as an explanation, let's see if we can get a microphone as well. Then we can hear that whether these hunted birds that were monitored are able to be seen as a pollution indicator. So if cormorants carry environmental pollution, is there anything else to investigate? Üllar Meriste from the Estonian Marine Environment Association. I just wanted to add to Lauri's presentation that Lauri was very optimistic that for 3 weeks the birds are in the smelt areas, but over the last couple of years they've been there for 2 months. They are present in the end of February and they leave end of April for the nesting period. So practically 2 months they're there. This was a specification, but anything to look into with the cormorants that you have hunted? Yes? Perhaps Timo is the expert here. One other specification with nutrition studies, the hunting only took place in the morning hours. So it's a very small time scale when these birds were hunted for nutrition studies. So the results of the stomach contact is based on a very short period in the morning, but Timo will definitely know more.
And quick explanation by Timo Arula. Hello. Thank you so much to Lauri for the presentation. As for the upcoming studies, then indeed, we took some swabs from the stomachs. We took some genetic samples to see, in case we have not covered all the species that could possibly be present in the cormorant's stomach, then we could find answers by using the genetic measurements. As for the marine pollution and other related matters, then we have made some suggestions for the studies, and we welcome some suggestions that you would like to do with us as well in terms of the pollution. Thank you so much, and now we will proceed.